Okay, so now we start the first of 3 sessions on what we would call traditional apologetics. So the existence of God today, next week is the reliability of the Bible, or is it truly God's Word? And then the last one simply is Jesus the Messiah? So we're going to be splitting those as we go. So you'll finally get Mrs. Bowen again next week. Get done with me for a while. Now, when we're talking about this idea of the existence of God, we have to ask this question. Can God's existence be proved? What do you think? Andrew? No? Faith?
I think you stated previously in a different lecture that you can't prove God's existence, but you can provide reasonable evidence for it.
Yep.
You can't really prove anything.
Well, you can in mathematics. You can have proofs.
Scientific reasoning,
No.
you can't really prove anything.
No. So, as I say, proof is rather subjective. God's existence cannot be proved in a mathematical or scientific sense. Instead, we should ask if belief in God's existence is reasonable. And that's what I'll be providing evidence for, that belief in God, as I'll say at the very end, is not only reasonable, but perhaps even necessary. Now, let's just say you're talking to a friend, maybe you just met somebody at a coffee shop, wherever, and they happen to mention, maybe even ask, that they don't believe in God. And you say, why? Well, there's just no evidence that God exists. I just haven't seen any evidence. Oh, well, so I just take a napkin, piece of paper, whatever, take out a pencil, pen, draw a big circle, like I have here, and just tell them, let's just suppose that this represents all the knowledge of humanity and culture and the universe, and it's all in that circle. All the knowledge that can possibly be known. And then ask them, how much of that do you know? Faith, what would you put on the paper? No? Daniel?
Just like a tiny line resembling a pie
Yeah,
shape.
maybe even just a dot.
Yeah.
That's the best I could do on PowerPoint. Okay. And then you simply follow up by suggesting, well, isn't it possible that the evidence for God's existence is outside of what you know? They'd almost have to say, well, because they're admitting there's a lot they don't know. And so you're just able to get them to a point where they're really moved a bit away from atheism and more towards agnosticism, which is simply saying, I don't know. Okay. Now we're going to have this interesting conversation here about life without God. It's true that each of us will one day grow old unless Jesus comes back, die, and our bodies disintegrate. Mrs. Bowen would prefer that happen today.
Yep.
Even before class ends. Nothing against you. Our bodies disintegrate. What then? I was in a graduate level class at the University of North Texas, and we had about a dozen graduate students in the Department of Ecology and Evolution. I was one of them. And then we also had the five professors from that department. And we were reading a book by a professor from Harvard, E.O. Wilson, and he makes the point in one of the early chapters that the only purpose in life is to survive and reproduce. And since we are simply just another organism, then that's our only purpose in life. So I knew exactly where that would lead them, and I could have just talked my way through it myself. But I chose just to ask some questions. First I asked, well, so you're telling me the only purpose in life is to survive and reproduce? I said, yeah. Well, let me offer a hypothetical here. Let's just say I'm dead, I'm in the ground, decomposers are doing their thing, talking to a biologist now, decomposers. And what difference does it make to me now whether I reproduced or not? A few seconds of silence. Finally, one of the professors speaks up and says, well, ultimately, I guess it doesn't really matter. I said, well, now, wait a minute. First you tell me the only purpose of life is to survive and reproduce. And now you tell me that that doesn't matter either. So what's the point? Why go on living? Why stop at red lights? Who cares? A few more seconds of silence. Professor finally speaks up again and says, in the future, those who will be selected for, meaning those who will carry on the human race, will be those who know there is no purpose in life, but will live as if there is. See what he just said? The only way the human race will continue will be because of those who can live a lie. And they know it's a lie. Well, I let it sit there. I didn't ask any more questions. I didn't make any comment. I just let it sit. And I talked to a few of the grad students over the next couple of days, and one I talked to was only a few. But so, what did you think about Dr. Fitzpatrick's responses to my questions yesterday in the seminar? Well, I don't know. Something just seemed wrong about it. Something just didn't seem right. I said, well, you followed his evolutionary logic, right? Oh yeah, that made absolutely perfect sense. What was reacting against it was the image of God within them. They couldn't detail what was wrong, but just knew something's not right with that. As I say here, if the moral and the immoral eventually come to the same end, what does it matter how we live our lives? If there is no future after death, if you die in your dirt, it makes no difference how you live your life. It makes none whatsoever. Maybe you want to make those around you happy. Okay, fine, that's good for you. Maybe you just want to get a menial job that can pay rent, buy food, and you play video games all day. If that's what you think your end is, then why not? Actually, some of your generation, some of the older generations, that's exactly what some of them are doing. They're just making enough money to pay rent, to buy food, and they spend their day playing video games. They don't want to get a career. They don't want to do anything like that. So, further, life without God. This is the quote from E.O. Wilson. He says, no species, ours included, possesses a purpose beyond the imperatives created by its genetic history. That's survive and reproduce. We have no particular place to go. Now, he's being fairly honest about it. But yet, he was married, he had one child, but he didn't really have much involvement in the raising of his daughter. He just kind of spent all his time up at Harvard University, up in the lab, doing his work with ants and all those kind of things. I say here, life without God is absurd. Well, if there is no God, and as I've been saying, then all these things, there is no purpose, there is no plan, there's nothing to be fulfilled, you die in your dirt, then that's an absurd life. Who really wants to live that way? Who really can? So I'm going to give you several areas of evidence here. We're going to talk about what's called the cosmological argument, or the beginning, and trying to answer the question, why is there something rather than nothing? Then we'll talk about the teleological argument. That's asking, the things in the universe and life, do they appear to be designed? And then there's the moral argument, where we ask what ought to be, not simply what is. Now, I'm using argument here in the philosophical sense. When philosophers make an argument, they present one or two or three lines of facts that they think are true. And then they draw a conclusion from that. It's called a syllogism. Fact, fact, conclusion. And we're going to be offering you some of those here. So, almost every cosmologist, astronomer, physicist will grant you that the universe had a beginning. That's not what they were looking for. They were planning on the universe having been infinite. Because anything that had a beginning must have been caused by something else. You can't cause yourself. Something else has to cause you to come into being. And something can't come from nothing. Okay. Therefore, we can conclude, if those two statements are true, our conclusion, therefore, the universe was caused by something else. Now, we can say here, creator, but that's not where the syllogism takes you. It only shows you that something else caused the universe. The universe didn't do it itself. Now, the current theory is the Big Bang, and this is just a globular cluster, but it kind of looks like a Big Bang of stars and everything like that, so that's why I just put that up there. Hubble Space Telescope gives us some wondrous photographs. The James Webb's doing even better. How many of you know the comic strip Calvin and Hobbes? Who's ever heard of it? No? Well, it's about this young boy, probably about kindergarten age, maybe younger, Calvin, and his pretend friend who's a tiger known as Hobbes. And it's no longer currently being written, but there are at least a half a dozen books with all of those cartoons in them. And most of the guys in the class yesterday had all those books and they were familiar with this cartoon. So here we go. We're going to start out here. And in the upper left, Calvin says to Hobbes, I've been reading about the beginning of the universe. They call it the Big Bang. Then Calvin says, isn't it weird how scientists can imagine all the matter of the universe exploding out of a dot smaller than the head of a pin, but they can't come up with a more evocative name for it than the Big Bang? That's the whole problem with science. You've got a bunch of empiricists trying to describe things of unimaginable wonder. And Hobbes says, what would you call the creation of the universe? The horrendous space kablooey. Hobbes says, lower left, that is better. Calvin says, almost anything would be. We should lobby to change that. And I think Tyrannosaurus should be changed to monstrous killer death lizard. Our older son really liked Calvin and Hobbes, and he just started to emulate Hobbes a little too much, or Calvin, I should say, a little too much, and we started having to hide those books from him. So, the Big Bang, or the horrendous space kablooey. Now, here's what they'll tell you. The universe began as a particle that was infinitely dense, occupied no space. Now notice the word particle is in scare quotes. They really can't call it a particle, because if it doesn't occupy any space, it's not matter. Matter is anything that has mass and occupies space. This particle doesn't. Nobody can tell you what it is. It's just something that's there. And it didn't just come out of nowhere. It really did come out of nowhere. It couldn't have existed for eternity and suddenly exploded, because that would have meant something internally. It's infinitely dense. Nothing internally can change. So why would it exist for eternity and suddenly explode? So to literally say that this little particle just blooped into existence. Now, another syllogism here. Something must be eternal. What do you think about that? Something must be eternal.
Like something's outside of the system, because our system had to have something else that created it.
Our system had to have a beginning, so something else outside of it had to cause it to come into being. Well, the material universe had a beginning and therefore is not eternal. Well, if the physical universe is not eternal, well, something also has to be eternal, because you can't get something from nothing. Something has to have always been here. Therefore, something spiritual or supernatural, material, must be eternal. Now, still, I put the word supernatural in there, but the syllogism really doesn't exactly tell us that. All we know is it's non-physical, whatever this is. Now we're going to look at some reactions to some of the astronomers to this realization. Philosophically, the notion of a beginning is repugnant to me. What's repugnant mean?
I have no idea.
You're offended by it, basically.
All right, thank you.
You're offended by it. I should like to find a genuine loophole. We must allow evolution an infinite time to get started. Astronomer from the early 20th century. Another one said it's simpler to postulate creation ex nihilo, divine will constituting nature out of nothingness. Yes, that is simpler. Anything else is making things too complicated. And it's not going to happen that way. And this next quote I'm going to give you here is from Robert Jastrow. And he was head of the Goddard Space Institute. He wrote a book quite a few decades ago called God and the Astronomers. And what he was documenting, these quotes came from his book. And he documents how so many scientists were repulsed by the idea of a beginning. There had to be, this can't be the way it really is, even though that's where the evidence points. So he said, for the scientist who has lived by his faith in the power of reason, the story ends like a bad dream. He's scaled the mountains of ignorance. He's about to conquer the highest peak. As he pulls himself over the final rock, he is greeted by a band of theologians who've been sitting there for centuries. They all knew for centuries that the universe could not have started itself, could not be eternal. So now we move to the teleological argument, simply as is the universe and life designed. First, when we look at our universe, there's far more now than 35 fine-tuned parameters that you can't keep track of them anymore. But what's listed for you are the four basic forces of nature: gravity, electromagnetism, and there's a strong nuclear force, and there's a weak nuclear force. Each of them can be expressed by an equation, a scientific equation, a mathematical equation. And within each one of those equations is a number they call the constant. They've simply determined that this number, this value has to be there in order for your calculation to turn out correct. And it turns out that the constants in those equations are quite finely tuned, or are just right. Now, with this explosion, this Big Bang, all these different forces could have had all kinds of values, could have been represented by all kinds of different kinds of equations. There's nothing to assure that they came down to these equations with those constants. Now, the gravitational constant in that gravitational equation, one astronomer put it this way. He said, if you were to take a ruler and stretch it all across the universe, that's a lot of inches. And it's marked off by inches. The gravitational constant is so finely tuned that it had to be within a value of within 1 inch. Otherwise, the universe wouldn't exist. Yeah. Something seemed to be at work here. Also, the ratio of the mass of an electron to the mass of a proton has to be exactly right, or else atoms wouldn't exist. Proton's too big, too small. Electron's too big, too small. No atoms. Now, this also was interesting. Just to give you an idea of the immensity of things. Now, this is called the gaseous pillars in an area called M16 in our own galaxy. Also, HST is the Hubble Space Telescope. Now, can you see at the very top, can you see a little finger-like projection? Make that out. Right up there. See it? Okay. We're going to zoom in. Now, this is just gas and dust. Some of them are thinking this is where stars are forming, whatever. We don't know for sure. But they were able to tell us that the width of that little finger is the same as the width of our entire solar system. From the sun out to Pluto. It's a lot of gas and dust, man. Also, I'm going to show you a photo taken from the area of Mars of planet Earth. Can you find it? Planet Earth? It's a pale blue dot. And some have used that photograph to show just how tiny and insignificant our planet is. Why should you think we're so special?
Did everybody see the pale blue dot?
Okay. Now we're going to talk about our solar system. And if you look behind you, you see some planets hanging from the ceiling. Back here, you see all the way on the right is Mercury, then Venus, then Earth, then Mars. And you see the big sun right there. By the way, it takes about 45 breaths to blow up that sun. I counted them yesterday. Now I can tell any boys I talk into doing it for me how much air it's going to take. And I have some pretty big lungs, okay? Mercury is about 36 million miles from the sun. Now, one side always faces the sun. Its rotation is the same as its orbital rotation. So one side's really hot, the other side's really cold. But it has no atmosphere. The sun's gases have just blown the atmosphere all away. Venus, on the other hand, has a gaseous atmosphere made up a lot of sulfur dioxide. It does have some carbon dioxide, it's mostly sulfur dioxide, which is poisonous. It's also mean temperature is about 200 or so degrees Celsius, which is twice the temperature of boiling water. And then you have Earth. We're 93 million miles away, and we're just in that sweet spot, what's called the circumstellar habitable zone. We're not too close, we're not as hot as Venus, we're not so far away, so we're not as cold as Mars. 20% either direction, further in or further out, life wouldn't be possible here. Our sun itself, it's the right size, it has the right temperature, it's the right type of sun. It's called a yellow dwarf, and it emits all of the wavelengths of visible light. And many of the harmful waves of radiation that it does emit, Earth's electromagnetic field bounces all that stuff away. And photosynthesis depends on violet light and red light, almost the two opposite ends of the visible spectrum. So you need all the visible spectrum for photosynthesis to work. About Earth, our moon is fairly large compared to the size of its planet. It's the largest moon compared to the size of its planet. And it revolves around us every 28 days or so. That's how they marked a month in the early days. And it's large enough and its orbit stable enough that Earth is tilted about 23 degrees. And the moon stabilizes the Earth's axis. If the moon wasn't there, we'd wobble a lot, okay? And that wouldn't work out too well, because sometimes you get a real long, hot summer, and a couple of years from then you get a really long, cold winter. And there would be no prediction of seasons. We don't rotate too fast, we don't rotate too slow. Makes a difference. Composition. Inside the Earth, at the very center, is an iron and nickel core. And it's under such great pressure and such immense heat that even though they call it a solid, sometimes they'll refer to it as liquid because it does kind of circulate. And it's that circulation that creates the electromagnetic field around the Earth. So you need that iron nickel core. You need some movement in it to create a magnetic field. There's the size of the Earth compared to the sun. Don't want to get too much closer to the sun. 93 million miles is about right. Now, a little video here for about the moon.
Fabulous! The requirements for producing a total eclipse of the sun are a luminous body, in our case the sun, an eclipsing body, in our case the moon, and then an observer platform, in our case the surface of the Earth, and they all have to be in a straight line in space. The apparent size of the moon in the sky has to be almost exactly the same as the apparent size of the sun in the sky. They're both about half a degree. The sun is 400 times bigger than the moon, but is 400 times further away. So there's this coincidence people have noted for centuries, but they just say, oh, well, it's a coincidence, and shrug their shoulders.
As Gonzalez examined this rare alignment of sun, moon, and earth, he recognized the importance of these celestial bodies to the existence of complex life on our planet. The gravitational pull exerted by our moon, for example, is strong enough to regulate the Earth's climate by stabilizing its tilt and helping to circulate the warm and cold waters of its oceans, while our planet's distance from the sun permits both liquid water and an oxygen-rich atmosphere.
You have to have the right distance of the observer's home planet from its host star, and you have to have a large moon, and so there's this very strong overlap between the requirements for producing eclipses and the requirements for habitability, for having a planet that can support life.
These striking events are not only compelling to observe, they also open a portal onto the physics and chemistry of the entire universe.
Really, you can think of eclipses as a giant natural experiment set up that allows us to observe a part of the sun that's critical towards understanding how its light is produced in its atmosphere.
The fact that the Earth is going around the sun and the moon is around the Earth, and the sizes and the distances between the Earth and the moon and the sun are just so to give you a perfect solar eclipse is a wondrous thing, because it allows us to measure the constituents of the upper layers of the sun's atmosphere.
During a solar eclipse, the moon fits so perfectly over the sun that it shields its blinding light, providing astronomers with a view of the star's atmosphere otherwise impossible to experience.
So was anybody here able to observe the solar eclipse from last April?
Yes.
Yeah? No? I'm sorry. We were in our backyard.
I did see a bit, but the clouds.
Yeah, we had clouds come over us too, but
We had it clear.
you had it clear? Oh, I'm so grateful. I'm so happy for you. Okay.
It cleared out just before it happened, so we were really happy about that.
Yeah. Well, it was clear up until the full eclipse happened. Then we had clouds come over. Well, it was disappointing. But the Hope Center, people were up on the top of the garage viewing it, and they were able to see it. And that's about 4 blocks away from us.
Two
2
blocks away.
2 blocks away were able to see it, and we didn't.
And people at Theo, they were half a mile away from us in the other direction. They were able to see it.
They saw it. Oh well. So here you see all of the planets of our solar system. Jupiter and Saturn are important for another rather unusual reason. Since they are so large, they have a large gravitational pull, that the fact that they are outside the orbit of the inner 4 planets, Jupiter and Saturn, because of their large mass and their large gravitational field, as comets and asteroids are whirring around, they pull those in. And we got to see one of those quite a few decades ago. I forget what the name of it was, but we saw a meteor get pulled into the planet Jupiter. And there were photographs of it getting closer, and then dipping beneath the clouds. They suggest that with Jupiter and Saturn there, the frequency of such an impact of a meteor on Earth is reduced about 1,000-fold. And they say that we've had a meteor impact about every 11 million years. So if you reduce that by 1,000-fold, that would be every 11,000 years. And life would not survive that very well. Also, Jupiter and Saturn stabilize the near circular orbits of these 4 inner planets, so that they remain fairly circular. Without Jupiter and Saturn, their orbits would be elliptical, and they would likely cross paths with each other, which would make for some eventual big collisions. Life wouldn't exist very well.
The presence of liquid water is a necessary condition for life, but it's not a sufficient condition. After all, there may be liquid water under the frozen surfaces of Mars and Jupiter's moon Europa, but there's very little chance that complex life exists in either of these places. You see, contrary to what the Copernican principle might suggest, the recipe for life is much more complex than just add water.
If a recipe for a planet capable of supporting complex life really did exist, then what ingredients, beyond liquid water, might be required? The list of necessary factors continues to grow.
A lot of things went right on Earth to have yielded complex life, absolutely.
The number of factors that have been postulated has grown. Currently, the typical number you would see is, in a typical list, would have something like 20.
We find that we need to be at the right location in the galaxy, that we're inside the circumstellar habitable zone of a star, that we're in a planetary system with giant planets that can shield the inner planets from too many comet impacts, that we're orbiting the right kind of star that's not too cool or not too hot, that we're on a planet that has a moon that can stabilize the tilt of its axis, that we're on a planet that's a terrestrial planet, a planet that has a crust that's just thick enough that it can maintain plate tectonic activity, that has enough heat in its interior that it's still circulating its liquid iron core so it can generate a magnetic field, that has an atmosphere that has enough oxygen to allow for complex organisms to survive, that has enough water and enough continents to allow for the diversity of life or an active biosphere that you need to support complex creatures such as ourselves. All these factors have to be met at one place and time in the galaxy if you're going to have a planet as habitable as the Earth.
Anybody want to be with that guy at the top of that mountain? No?
That'd be cool.
Yes. I usually get a no answer to that question. Okay. Now, they mentioned the list of about 20 factors. I'm going to give you a much larger number here, calculated by another Christian astronomer, Hugh Ross. And I've spoken with Guillermo Gonzalez about his number of factors, and he thinks Hugh Ross overplays it a bit. But you need to have a good understanding of probability. Once I gave this presentation in California, I simply asked, does California have a lottery? And he said, yeah. What are the odds of winning the lottery? Let's say 1 chance in 23 million. Okay. Now, probability folks will tell you if you sell around 10 to 11 million tickets, someone will win. And by that they mean they have enough what they call probabilistic resources for there to be a winner. Now, what happens if nobody wins the jackpot?
Doesn't it add to the next one?
They increase the jackpot. What does that do?
People buy more tickets.
People buy more tickets. So you have more probabilistic resources, increase the probability somebody will win. So we can say that improbable events happen all the time. But let's drastically lower the probability and dramatically raise the specificity. Let's say you have a neighbor who's played the lottery every week for decades now and never wins. One day your neighbor finally wins $4 million. He comes running out of his house, he's got the ticket in his hand, he's just so excited, throws a big party. Of course, you're his next door neighbor, you're kind of hoping, okay, maybe some of that cash can be used to fix the fence that you kind of neglected between, maybe I could benefit some, you know. And, well, it's no big deal to the lottery commission. Somebody was bound to win, and they just examine the ticket and they award the money. But what about the same person winning that same lottery 3 weeks in a row with the same set of 6 numbers. Anything seem odd to you about that?
It seems rigged.
Well, you suspect cheating. What you actually suspect is intelligent design. Somehow he was able to pay someone to rig the appearance of the lottery numbers to make sure that his, even if there were a different set of numbers, as long as they were the ones he wanted, it's the same result. Because the probability of winning it 3 weeks in a row, 1 chance in 23 million times 1 chance in 23 million times 1 chance in 23 million, which equals 1 chance in 12 sextillion. Now, we have about 8 billion people on the earth today, and in order to have enough probabilistic resources for that to happen, each person on earth would have to purchase 1 million tickets. Oh, a trillion. Not too many trillionaires in the world, but 8 billion of them. So, never been enough people in human history to ever sell enough tickets. The Lottery Commission will investigate. So now we come to, so you just keep those probability things in mind there. Huros comes up with 816 parameters. Each of them would occur by chance, and he calculates an overall probability for each one of those, and then he multiplies them all together. And the number he gets is 10 to the minus 1054. That's a 1 followed by 1054 zeros, or I'm pretty sure I counted all those zeros, right? Okay. So that's a decimal point followed by 1053 zeros and then a 1.
And what does that number mean again?
That's the probability of all those parameters occurring by chance. But we've talked about how large our universe is. We estimate that there are about 10 to the 22nd stars in the universe. And if we make a very simple assumption, say there's 1 planet per star, then you have 10 to the 22nd planets. So how do you calculate then how many planets could be suitable for life using our previous probability and this very, very large number? Well, you multiply 2 together. 10 to the minus 1054 times 10 to the 22nd gives you 10 to the minus 1032.
Not much different.
Or that many planets suitable for life by chance in the universe. Even the Earth has drastically beaten the odds if it all happened by chance. How do you think you'd calculate the probability for there being 2 planets to harbor life by chance? You'd multiply that number by itself, and you would get 10 to the minus 2064. So if we came about by chance, we are alone. Now, it's certainly possible God has created life elsewhere. It's the only way there'd be other life on the planet. But he didn't tell us anything about that, so I just assume we're not there. George Greenstein, as we survey all the evidence, the thought insistently arises that some supernatural agency must be involved. Is it possible that suddenly, without intending to, we have stumbled upon scientific proof of the existence of Supreme Being? Now, he doesn't understand science very well if he says scientific proof. Right? Now, also what he's indicating here is that they expected the universe to be eternal. Another philosopher said if we need an atheist for a debate, I go to the philosophy department. The physics department isn't much use. They know too much. So what about biological design? Well, here's this quote from Richard Dawkins. that give the appearance of having been designed for a purpose. And I love this quote from Francis Crick. He's the co-discoverer of the structure of DNA. Biologists must constantly keep in mind that what they see was not designed, but rather evolved. They have to constantly keep this in mind. Why? Because everything they look at looks designed. But they have to keep telling, no, it's not. Not designed, not designed, not designed. It can't be. Now, we spent a portion of time late August last year in Cambridge, at Cambridge University, where Francis and Crick did their work. And there was a special pub that they had gone to frequently during the week as they were working on the structure of DNA. And one day they came barging in, the patrons knew them, bartenders knew them. We have found the secret of life. And that day was February 28th, 1953. The very day Mrs. Bowen was born. The very day. The very day. Not just a birthday, but the very day.
So we went to that pub and had lunch to celebrate.
She likes celebrating.
Oh, I do.
She does that.
Any reason to celebrate. I am God's party girl.
She does call herself that. It's just, you know. What about evolution? There are a number of definitions of evolution that we could call a fact. Sometimes you'll see evolution used as simply a description of change over time. People will say politics evolve. That just means change over time. That happens. Or we could say it's changing gene frequencies in natural populations. We have charted that. I did research charting that happening in natural populations. Natural populations changing in response to environmental changes. We've documented that too. If that, you could say, is a fact. New species arising naturally. We have observed that happening. At least we've seen the results of it. One species, a few years later, there's two, and they're both really similar. They just might eat slightly different food sources. But all new adaptations due to mutation, natural selection, that's a theory. If they're going to explain all of the supposed design of life by mutation, natural selection, that's a theory. They would say there's plenty of evidence to support it. There's another one. All organisms descended from a common ancestor. That also is a theory. That is not a fact. Sometimes they're both taught as facts, but they're not. But the one we're most focused on here is that first one, all new adaptations due to mutation and natural selection. That is a theory. Now, you've had this discussion with irreducible complexity. Mike B. introduced it. Some of you had this in your quiz answer. Something is irreducibly complex, composed of two or more necessary parts. Remove one part and function is not impaired, it's destroyed. And he used the mousetrap as something that was irreducibly complex. Well, there's the mousetrap. The mousetrap has 5 necessary parts. It has a base that everything attaches to. You see, so that's the platform. You have a catch, you have a holding bar, you have a spring, and you have a hammer. I always carry a mousetrap in my computer bag. And TSA has never accused me of having a weapon in my computer bag. Well, okay, so here's the platform, here's the holding bar, here's the catch, there's the hammer, here's the spring. Now, to set the trap, first you put the bait here on the catch. And you pull the hammer back against the force of the spring, take the holding bar, put that on top, and then you lightly secure it to the catch. And the mouse comes along, nibbles, and there you go. I did this once with a rat trap with a group of students at a church, and sometimes I've used a pen. It doesn't break with the mousetrap. But when I used it for the rat trap, the pen did break, and I borrowed the pen from the lady whose ink spilled onto her blouse. So I never used the rat trap again. I used it because it's bigger. Everybody can see it better. But Don't do that anymore. Now, he said a mousetrap cannot be built by natural selection. Makes sense, right? Because all parts have to be there. They all have to be integrated. If this hammer was this big, it wouldn't work. You couldn't, if the holding bar wasn't long enough, you couldn't set the trap. So they all have to be coordinated in size and the strength of the hammer also. Well, B, he showed that the cell, which was Darwin's black box, is filled with irreducibly complex molecular machines. That's where some of you were a little inaccurate in your essay question. He didn't talk about the human body that much. He talked about blood clotting, but mainly he was focused on irreducibly complex molecular machines inside the cell. Now, what you show here is his favorite, one of his favorites, the bacterial flagellum. And it's just fascinating what you have here. You have, well, here's the filament or the propeller. There's a universal joint that determines which direction the propeller is going to work. There's an L ring and a P ring or a bushing. There's a rotor with an S ring and an M ring. And there's a stator with studs and C ring. An outboard motor has the exact same sets of parts. This one, however, is much more energy efficient than anything we can produce. Now, David Hume criticized Paley's watchmaker argument because it was not exact enough. When he talked about Paley's watchmaker, you find a watch in the woods, a watch implies a watchmaker. Well, Hume simply said, there are no watches in nature. That analogy doesn't work. Well, now we have them. We have all kinds of there you can see the universal joint rotating, and here you can see the filament. Over 100 molecular motors now known to exist, all with very specific analogies to human-designed motors. The cell is a cellular high-tech factory, has artificial languages, RNA, DNA, protein, memory banks, chromosomes, precision control of automatic assembly, protein synthesis, proofreading, quality control, prefabrication, modular construction. That's how the flagellum is built. Complete replication system. Now, this computer is pretty amazing, and it can do some amazing things, but imagine if I came to Dell and asked them, okay, what I want now, I want you to create a computer just like this one that can reproduce itself. No. They're just going to say no. Not even going to try. Well, here's the difference between complex but not specific, specific but not complex. In the background is a highly complex of volcanic rocks and along a beach. And they're in what now appears to be a very specific formation. The probability of exactly that formation is extremely low. But it doesn't mean anything. They could have assembled any other kind of formation and it still wouldn't mean anything. So it's not significant that that's all that improbable. You look in the foreground though and you see this, what looks like a circle. And that looks a little specific, but there's not that many rocks in there. Maybe 30, 40. I've never bothered to count. Looks like there's an entryway over here. Maybe there's a bonfire in there or something like that, but you're making assumptions here. You're guessing. You could probably have an interesting discussion about whether this arrangement of rocks could happen by chance or not. Let's say you go a little further on down the beach and you see this. Any chance that wind, rain, and waves did that? Well, what you have here, you have very precise symbols. They are letters of our alphabet. These letters are grouped together to form words. The words are put in a sequence to communicate a message. You don't have to know who wrote it. You don't have to know if it's true. It's a message, and it's clear that that's what that is. Now, we're going to look at Boston Dynamics was hired by the Defense Department to come up with a non-biological mule. And this is what they came up with. Okay, that's pretty amazing. But what about a real dog that can also reproduce? Which no mechanical big dog will ever do. Last argument, moral argument. Well, I'm going to make the case there is such a thing as objective morality. Objective morality would mean there's an objective moral lawgiver. And so we're going to conclude that there is a moral lawgiver. Now, moral laws are different from natural laws. Moral laws describe what ought to be, not simply what is. As C.S. Lewis put it, human beings all over the earth have this curious idea that they ought to behave in a certain way and cannot really get rid of it. If no set of moral ideas were truer or better than any other, there would be no sense in preferring civilized morality to savage morality or Christian morality to Nazi morality. In fact, of course, we all do believe that some moralities are better than others. The moment you say that one set of moral ideas can be better than another, you are in fact measuring them both by a standard. Comparing them both with some real morality, admitting that there is such a thing as a real right, independent of what people think, and that some people's ideas get nearer to that real right than others. So that's simply saying there is an objective moral law. It says, my argument against God when he was an unbeliever was that the universe seemed so cruel and unjust. But how would I got this idea of just and unjust? A man does not call a line crooked unless he has some idea of a straight line. What was I comparing this universe with when I called it unjust? Were the terrorist attacks of 9/11 wrong for all people all time? But if there is such a universal objective moral law as we've demonstrated, then there must be a moral lawgiver. So, last point here. Does evil exist?
Yes.
Walking up to a healthy, intelligent 2-year-old and cutting off their head with a machete in front of mom, dad, grandma, and grandpa. No. Is that evil?
Yeah, I'd say so. Very descriptive.
Average Tuesday.
If evil exists, then the opposite must also exist. The opposite of evil is good. What would be the source of good?
God.
Humans?
Definitely not.
Definitely not. God is the only source of true good. So our summary here. Life without God is absurd. The universe requires a sufficient cause. The design of the universe and living things implies a designer. Our universal sense of right and law implies a lawgiver. The existence of evil implies the existence of good. The source of goodness is a good God. Therefore, belief in God is reasonable, if not necessary. Convinced? Hope so. Okay, that's it.